how are you? I hope you all are doing great today. My name is Renurati and today we will be learning our very interesting topic, that is symmetry and pattern. Now in this chapter we will learn about what we have learned earlier: reflection symmetry, line symmetry, slides, flips and turns, identification of patterns in the square and triangular numbers, patterns in triangular numbers, Pascal triangular numbers, observations based on the Pascal triangle, and we will learn some relation in the sequence of odd numbers between the consecutive squares. Now let us start with, we have to complete the given patterns. Here we have to complete this pattern. Now our first pattern is plus, then multiplication symbol, then here we have plus symbol, then multiplication, then plus and then multiplication. That's how you have to complete the remaining ones. Now let's start with introduction to symmetry. Now symmetry is all around us in nature and it is an important geometrical concept seen in nature and useful in every field of our life. Now on looking ourselves in the mirror, we find our ears, our eyes symmetrical about a vertical line. Now when a shape or a figure is divided into two equal shape and size, we call the shape or figure symmetrical and the phenomena is called symmetry. Now for example, left half of the adjoining figure is same as exactly of the right half. Now it means that if we fold the picture, both half would overlap each other easily. Symmetry is found elsewhere in the world. We can find symmetry in nature, architecture and art. Symmetry in nature, architecture, and here is the symmetry in art. Now let's start with the reflection symmetry and line symmetry. A figure is said to be symmetric when it can be folded and matched. Reflection symmetry, sometimes called the line symmetry or mirror symmetry, as it is easy to recognize because one half is a reflection of the other half. Now let's look at the line of symmetry. The face of the dog has been made perfectly symmetrical. The dotted line on the center is called the line of symmetry. Now look at this beautiful butterfly. It is folded in two halves. See that two halves match exactly here. Now the particular line created by folding the butterfly is the line of symmetry or the line of reflection. Now when the butterfly is folded at the line of symmetry such that two sides match each other exactly, so we can say that the two are congruent and the butterfly is our symmetrical. Now let us draw the line of symmetry of the following figures. This is our horizontal line of symmetry, vertical line of symmetry and diagonal line of symmetry. Now many shapes have multiple lines of symmetry or no lines of symmetry. For example, this figure has 4 lines of symmetry, this one has 2 lines of symmetry and this one has no line of symmetry. Now let's look at the symmetrical objects that are around us. Now we'll see some examples of symmetrical objects around us, that is the letters of English alphabet, traffic signals, geometric shapes and other images. Now here are the shapes in which symmetry exists. Symmetry exists in architecture all around the world and the best example of this is Taj Mahal. Line symmetry can also be shown in the letter of English alphabets. The capital letter B alongside has only one horizontal line symmetry. If we fold this from the horizontal line, its top and bottom parts match each other exactly. But the letter B does not have vertical line symmetry. Now when we draw a line vertically, the left and the right parts of B does not match with each other exactly. So the capital letter P below has no line of symmetry. Now let's look at the few letters of English alphabet. Here A has vertical line of symmetry, B horizontal axis of symmetry, O and J. O has both axes of symmetry and J has no axis of symmetry. Now let us try to make a word letter with vertical axis of symmetry. So the word here is hat. Let us now make a word of using letters with the horizontal axis of symmetry, that is choice. Now here is figures more than 2 lines of symmetry. Now look at the given figures. You will observe more than 2 lines of symmetry. Here is 1 line of symmetry, 1 line of symmetry, 2 lines of symmetry, 2 lines of symmetry. Next one has 3 lines, 4 lines and a circle has infinite lines of symmetry. Now when a figure is symmetrical, the other half of the figure can be drawn by looking at the given half. Here is the given half and we can draw this given half and we can draw the figure completely. Now let's start with exercise 11.1. In the first part, we have to choose the correct option and fill in the blanks OMR sheets correctly. Now which letter has the vertical line symmetry? that is T. In the next one, we have to decide whether the given pictures have vertical, horizontal or no line of symmetry. Put tick mark on the corresponding answers. Vertical symmetry, yes, it has vertical symmetry. That's how you can complete the remaining parts. Now in the third one, we have to draw the line of symmetry for each of the following. This is the line of symmetry. In the next one, we have to complete the symmetrical shapes. This is how we can complete it. Now let's start with slides, flips and turns. A slide takes place when a shape moves in one direction from one place to another. A flip takes place when a shape is flipped across a line and faces the opposite direction. Now next is our turn. A turn takes place when a shape is turned through an angle. Here is the original position, here is a quarter turn, then a half turn and then a 3/4 turn. Now here you have to draw a tessellation with pentagons or hexagons, then you have to draw a tessellation by a combination of two plane shapes, and here are our letters like D, P, M, Y, Z, and you have to read their images through a mirror and how does each other look like, that you have to do it by yourself. Here are the original position, 1/4 turn, half turn and 3/4 turns of alphabet T. Now next is our identification of patterns in squares and triangular numbers. Now patterns often occur in science and mathematics and they are formed by a group of shapes, objects, diagrams or numbers. Now patterns are the part of our daily life and are very useful in mathematics as they can help us to solve some problems. Now here are our patterns in square numbers. A square number is a number that can be arranged in a square pattern. The patterns of first three square numbers are depicted below. The first square number 1 is shown as a square containing a single dot. There is a row containing one dot and 1 into 1, that is one dot in this square number. Now the second square contains 4 as square with the 2 dots in each side, and it is clear that 2 rows containing 2 dots and 2 into 2, that means 4 dots in the square number. Next is the third square, 9 is shown with the square of 3 dots in each row and 3 into 3 is 9 dots in the square number. Now from the above discussion, we can make a series of square numbers, that is 1, 4, 9, 16, 25, 36 and 49. Now observing the above pattern, we can find that a square number is made by squaring it where it is in a pattern. For example, the second number 2 squared, 2 into 2 is 4 and the number 8 is the square of 64. Now let's look at patterns in triangular numbers. Now triangular numbers are those numbers which can be formed by counting the number of objects used in making a triangle. Now look at the other triangular patterns. From the above discussion, we can see that we can make a series of triangular numbers as well. Here is 1, 3, 6, 10, 15, 1, 3, 6, 10, 15. These are the triangles that we can form with this pattern. Now let's start with the Pascal's triangle. One of the most interesting number pattern is Pascal's triangle, named on Blaise Pascal, a famous French mathematician and philosopher. Now to build a triangle, let's start with 1 at the top and then continue placing numbers below it in a triangular pattern. Now each number is just the 2 numbers above it added together. Now 1 plus 1 is 2, 1 plus 2, 3, 3, 1, 1, 4, 3 plus 3 is 6, 3 plus 1 4 and 1. Now let's look at the observations based on Pascal's triangle. Now here are our diagonals. Of course the first diagonal is just 1s and the diagonal we are counting is, that is 1, 2, 3, 4, 5 etc. Now the third diagonal has the triangular numbers 1, 3, 6, 10, 15 etc. And the fourth diagonal, not highlighted, has a tetrahedral numbers like 1, 4, 10, 20, 35 and so on. Now let's look at the horizontal sum. Now what do you notice about the horizontal sums? Is there a pattern? Isn't it amazing? It doubles each time. Each time whenever you see it, twice of 1 is 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 32, 64 and 128. This is a pattern that we observed here. Now next is our Sierpinski triangle, an ever repeating pattern of a triangle. Let us learn how to create a Sierpinski triangle. Now we will start with the triangle. We will shrink the triangle to half and put a copy in each of the three corners. Now we will repeat step 2 for the smaller triangles, and again and again and forever. And in the first 5 steps we have learned that it is an infinite process and we can use any shape. Here you can use any shape. Here we took the shape of a frog, and these are the infinite triangles that we can make. Now you can make your own number patterns. You can use your own number patterns using coins, matchsticks, and here is an example using coins. For example, this is a size 1 and 1 coin, size 2 6 coins, size 3 15 coins, and size 4 that is 28 coins. Now how many coins would you need when your size is 5? That you have to tell me here. Now can you make a formula that will tell you how many coins are needed for any size, and the formula may be something like coins is equals to size into size plus. Now for example, in a series of square numbers, find the square numbers next to 121. 121 is 11 into 11 and the number next to this is 12 into 12, that is 144. 400 is 20 into 20 and 21 into 21 is 441. Now next is our, in a series of square numbers we have to find the square number just before 625, that is 625 is 25 into 25 and number just before is 24 into 24, that is 576. Similarly 96 is the square of 14 and number just before is 13 and 13 square is 169. Now let's look at example number 3. We have to, with the help of 15 dots, we have to create a triangular pattern. Now we can create a triangular pattern using 15 dots as shown in this figure. Now in next example, we have to tell the next triangular number after 28, 36. Then we will write the difference between them, that is 8, and the next triangular number is 36 plus 9, that is 45. Now let's start with example number 5. What makes smallest number should be added to 396 to make it a square number? As we know, 19 square is 361 and which is less than 396, and 20 square is 400 which is greater than 396. So that means to make it a square number we will subtract 4. After subtracting 400 minus 396 we get 4, and if we add 396 plus 4 it becomes 400, and therefore 4 should be added to 396 to make it a square number of 20. Now always remember, each side of a triangle has 5 dots. Now in example number 6 we have to tell which of the following numbers are square numbers: 11, 12, 16, 32, 36, 49, 56, 81 or 121. So numbers are 4 square, 6 square, 7 square, 9 square, 11 square are our square numbers. Now let's start with exercise 11.2. In the first part, we have given each shape a quarter turn to complete the pattern. Here we have to take it a 1/4 turn. So this will changes into this. Here we will draw a square. This one will be our pink one and this one will be our pink one. That's how you have to complete the remaining part. Now in the second one we have to generate the square and a triangular pattern with the help of 36 dots. Now 36 is triangular as well as a square number. For example, if we are doing it for a 3, we will draw a triangle like this. That's how you have to complete it for the 36 dots for square as well as triangle. That's how you can complete the remaining part. Next is our relation in sequence of odd numbers between consecutive square numbers. Now square numbers have several interesting properties. Let us see the following patterns for various properties. Pattern A is 1 into 1 is 1. 2 times 2 is 4, 4 is 1 plus 3. The first odd number is 1 and the sum of first two odd numbers is 4. Now 3 into 3 is 9. This is first 3 odd numbers. First 4 odd numbers 16, first 5 odd numbers 25. Now observing the above pattern we can conclude that the square number formed by n cross n is equal to the sum of first and odd numbers. Now here is our pattern B in this, as 1 plus 3 is 4 which is the square of 2, 4 plus 5 is 9 which is the square of 3, 9 plus 7 16 square of 4, 25 square of 5, 25 plus 11 36 square of 6 and 49 which is the square of 7. Now the above pattern can be represented pictorially as follows. We can represent it pictorially as 1, 9 plus 7 is 16, 1 plus 3, 4, 2 square, 3 square, 9 and 25, that is of 5 square. Now let's look at pattern number C. Look at the following pattern which relates a square number with another square number just before it. 7 into 7 minus 2 into 7 minus 1, that is 6 into 6. We took a number just below it, that is 6. Now it is a square of 5. Number took just below it, it is a square of 4. Now can you extend this pattern further? Now let's look at pattern number D. We see the following pattern carefully and write 3 more such relations between the square numbers. Now 3 into 3 plus 2 into 3 plus 1, that is square of 4, that is a square of 5. Again we took a greater number, that is a square of 6, again a greater number, that is a square of 7. Now let's look at example number 8. We have to express the following square numbers as the sum of 4 numbers. Now here is our 49, that is a square of 7, and 49 can be expressed as a sum of first 7 odd numbers. Now next is our 81, and 81 can be expressed as a sum of first 9 odd numbers, and it is a square of 9. Now let's look at example number 9. Without actual addition, find the following sum. We have to find the following sum, and given sum is a sum of first 11 odd numbers, and first 11 odd numbers are these, and it is equals to 121, which is the square of 11. Now let's start with exercise 11.3. In the first part, we have to express the following square numbers as the sum of odd numbers. So 25 can be written as 1 plus 3 plus 5 plus 7 plus 9. That's how you have to solve the second and third part. Now in the next one, by observing the following pattern, we have to generate the next 3 lines of these. So it can be 6 into 6 is equals to 1 plus 3 plus 5 plus 7 plus 9 plus 11. Next one will be 7 into 7 is equals to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. That's how you have to complete the remaining parts. Now let's start with the think tank. We have to take the correct option. The letter O of the English alphabet has many lines of symmetry. That's how we can complete the remaining part. Now in the next one, we have to consider all the capital or uppercase letters of the alphabet and classify them under the headings below. Now horizontal only, that is B. Vertical only, that is A. Both vertical and horizontal, that is I. Neither horizontal nor vertical, that is P. That's how you can complete the remaining part. Next is our activity zone. Now make a pattern on the top half of the grid and reflect it about the horizontal line AB. Now here you have to draw the top half. Top half is drawn. You can draw something like a triangle, you can draw here, and here you have to draw the lower half of this triangle and you have to reflect it with this horizontal line AB. That's how you can complete this pattern. Now I hope you have understood the chapter pretty well. You just have to practice exercise questions and don't forget to revise this topic again.